Hello, this is Britt Caswell with another example video. In this video, I'm covering example 1 from section 3-4 in the SavvasRealize Algebra 2 textbook. So in this video, we are going to use long division to divide polynomials. So before I start on that, let's go back to 3rd grade. And we're going to do a math problem in 3rd grade. So remember, when I do long division as a kid, right, we would say, well, can 13 go into 1? It cannot. Can 13 go into 15? Sure, one time, right? And I'd multiply 1 times 13 and write it down here. And then I would subtract it, right? And 15 minus 3 is 2. And then I would bring down my other terms, right? And then I'd say, well, can 13 go into 26? And I'd say, yeah, it can. It can go in there twice. And I'd say, well, 2 times 13 is 26. And I'd subtract that and get a 0. And then I'd bring down my 9. And so this would be my remainder. That means that 13 is not a factor. That's going to be a big deal later. So 13 is not a factor of 1569. Bummer. But because I couldn't divide out that 9, I would have to put in a 0 here, because it wouldn't work. So that's how to do it as a little kid, right? So now you're going to see that when I go to do polynomial division here, that I'm actually going to follow the same steps. So let's check it out. So when I do polynomial division, I just look at the x and the first term that's there, okay? So what do I have to multiply x by to make it look like x cubed? Well, that would be x squared. I'm going to change colors here actually for that. I think it might be easier to see. So there's x squared. So now I'm going to take that x squared and times it times this binomial to write down here. So x squared times x is x cubed, and x squared times 3 is 3x squared. Do you guys see how I'm doing the same math problem here, by the way? 1, 5, 6, 9. 1, 5, 6, 9. 13, here's a 1 and a 3, okay? So just like over here where I had to subtract by 13, I'm going to have to subtract this polynomial. Now the biggest mistake that kids make when they go to do this is they forget to subtract all of the terms here. But just remember, with our old division, right, I wouldn't subtract the 1 and add the 3, right? So I need to make sure that I do it to both of the terms. So x cubed minus x cubed, that cancels out. And 5x squared minus 3x squared is 2x squared. And then I'm going to bring down the rest of my stuff. Alrighty, so now I ask myself, what times x makes it look like 2x squared? Well, I would certainly need a 2, wouldn't I? That's too red. So I need a 2, and then I need another x. So now 2x times x is 2x squared, and 2x times 3 is 6x. And then I need to subtract that, right? So 2x squared minus 2x squared cancels out, and 6x minus 6x cancels out. So the only thing that comes down is this 9. Now to make x look like 9, I would need to times by something weird. So this is actually where we stop. Instead of filling in a 0, we would just say, well, my power that's down here that I'm dividing by is less than the power here, so I don't need to use that. So this remainder is now what we would need to put up here. So in third grade, right, we would put plus a remainder of 9 over 13, like that. Here in Algebra 2, we would put the same kind of remainder, so plus 9 over x plus 3. So I also wanted to go into a little bit of vocab, just so that you remember what some of these words are, and you understand why they're using the letters D and Q and stuff like that. So recall that in here, this is called the dividend. A lot of times they'll call it P of X, which is dividend, not dent. Now out here, this is called the divisor, and this is called the quotient. So they're calling that D of X to stand for divisor of X. And then you'll also see Q of X, and they'll call the remainder R of X. So those are some of the words that you might see coming through all this. So now let's look at example B. So with example B, I'm dividing by 2x plus 3. And if you notice, the polynomial that we're dealing with goes straight from x cubed to the constant. So I need to put in my square term, linear term in there. Like, I can't just not have them. So I'm going to put a 0x squared and a 0x before I put the 27. And the reason why is, do you see that when I go to do this division, how I have columns of each number, like each number type? I have to have that here as well. So if I don't put in those placeholders, my division gets really ugly and it kind of does this weird warping thing, which can get quite confusing. Alright, so what do I multiply times 2x to make 8x cubed? Well, that would be 4x squared. So I'm going to multiply 4x squared times 2x plus 3. And that gets me 8x cubed plus 12x squared. And I'm going to subtract those. So when I subtract them, the x cubes cancel, and 0x squared minus 12x squared is negative 12x squared. And I like to bring down my terms as I go. I find that that's easier to keep track of my progress. So now I ask myself, what do I multiply times 2x to make negative 12x squared? That would be a negative 6x. So if I multiply that out, I get negative 12x squared, and then negative 6x times 3 is negative 18x. So do you see how it's kind of, these lines are becoming more important to fill in the zeros? Otherwise the 27 would be here and I wouldn't have room, right? So that's why I filled it in. So here we go, so that cancels. Now 0 minus negative 18 is the same thing as doing 0 plus 18. So this is going to be a positive 18x plus 27. And then to go from 2x to 18x, that would be a 9. So 9 times 2x is 18x, and 9 times 3 is 27. And when I subtract them, this is a perfect fit. The remainder is 0. So I don't need to write the remainder out. That's my final solution up here. Sorry, I'm just looking at write it in terms of the quotient and remainder. So when it says to write it as a quotient and remainder, it's asking you to write it like this. Eventually they're going to ask you to write it as the quotient times the divisor, and then add the remainder, so I'll be showing you that in another way. But this is our answer, and this is our answer. Alright, so let's try another one. So this time I'm dividing by x squared minus 4x plus 3. Oops, it's a minus 6. It's a big deal. Make sure you copy things correctly. Okay. So to go from x squared to x cubed, I just need an x, right? So x times x squared is x cubed. X times negative 4x is negative 4x squared. And then we'll have a plus 3x there. So when I subtract, these first terms cancel. Negative 6 minus negative 4 is negative 2x squared. 11 minus 3 is 8x. And then I drop down my minus 6. So to go from x squared to negative 2x squared, I need a negative 2. So now I'm multiplying it out, so negative 2 times negative 4x is plus 8x. And negative 2 times 3 is a negative 6. And then I go to subtract that. And if you notice, I'm subtracting the same polynomial from itself, so that tells me I'm going to have a 0 here. So my final solution here is x minus 2. And this is telling me that x squared minus 4x plus 3 was a factor of the polynomial. Right, and then we're doing one more example of long division here. So I have 4x squared plus 9. Now notice this is jumping from the fourth to a linear term. So I'm going to put in those placeholders to keep my math clean and clear. So my cubic, quadratic, and linear term, they all have a coefficient of 0. And again, that's just to keep my lines nice when I go to divide. So to go from 4x squared to 16x to the fourth, I need to multiply by another 4x squared. So now I'm going to multiply those. So 4x squared times 4x squared is 16x to the fourth. And 4x squared times 9 is going to give me 36x squared. Now notice this is a little strange because there was a gap where the x to the third is. That's because there wasn't a linear term here. So if you need to put in a linear term so that you don't freak out about that weird space, you do you. You know what, it's fine. So here this cancels, and then 0 minus 36x squared is negative 36x squared. So then I go about dropping down all my placeholders and stuff. Now this 0x cubed, I'm not going to drop it down because then I would have to put in a 0x here and I don't need it. So he's just fine just staying where he's at. So now here we go. So to go from 4x squared to negative 36x squared, I need a minus 9, a negative 9. So negative 9 times 4 gives me a negative 36x squared here. Oops. And then negative 9 times 9 gives me a negative 81. And then I'm going to subtract them. So here this cancels. And then negative 85 minus negative 81 gives me a negative 4. And I don't need to drop down that 0x because he can't get divided by that anyway. So I have a negative 4 of a remainder. So what I'm going to do is write this remainder up here as minus, because of the negative, 4 over 4x squared plus 9. So this is my solution. So there you have it. There are a few examples on long division of polynomials. I hope that helps. Until next time.